hate to correct somebody that's so generously introduced me, but you amalgamated two things. The thing that was published in 2016 was my most recent book, which is called How to Be Good. And I hoped that everybody would think it was a sort of self-help manual. But actually it is about the whole issue of trying to use science to make people morally better rather than simply physically better or cleverer or longer lived or all the other enhancement technologies. So that's what that's about. But this is not what that's about, at least not entirely today. I usually issue several health warnings to when I speak. The first is that I'm a philosopher. That means, what that means for you is that I use no visual aids that were not familiar to Plato. Largely on the grounds that if a technology isn't broke, you don't try to fix it. And we've been talking to each other with humans for millennia, and I hope we can continue to do that this evening. So no visual aids at all. In fact, actually, do you want to know your Plato? Of course you do. Of course you've all read the dialogues. Well, of course, Plato did recommend the use of one visual aid. Those of you who know your Plato will know that it was a very deep cave with a very large fire in it, which projected shadows onto a wall. But in most of the places which I'm privileged to speak, they absolutely draw the line of a very large fire, let alone digging a very large hole in the floor in order to accommodate visual aids. I'm going to try to talk this evening about two new technologies. They are both technologies which are capable of and notorious for making inheritable changes to the human genome, changes that will be passed on from generation to generation. And the idea of doing that has raised a lot of anger and worry and objections. The meeting I'm going to speak at in Paris tomorrow is run by a very distinguished French neuroscientist who thinks that one of the biggest dangers facing science is overhype, exaggerating what it may or may not do. I think that is a very big danger, but one of the other big dangers is the danger of exaggerating its dangers and forgetting its advantages. And later on in the talk, I'm going to talk about some of the very powerful uses to which gene editing may be put. But I'm going to start at the beginning, so to speak. The two technologies that have arisen in the last 3 or 4 years in public notice. One is the use of Crispr Cas9 in particular, to edit genes, to actually change genes or insert new genes into the human genome, and also mitochondrial replacement therapy, which will allow many women with mitochondrial disease to have healthy children. But of course that therapy also will make changes to the genome, permanent inheritable changes to the genome of those children. The American Nobel Prize, I also spoke, the NIH, which is in the US, the National Institutes of Health, organized 2 summit meetings, one in 2015 and one in 2016, on these two technologies, the first on mitochondria and the second on gene editing. And I spoke at both of those, and they were convened by David Baltimore, who is a Nobel Prize-winning American scientist. Now, he's insisted bioscience capacity and ones in which tight regulation of such science exists or can be established. Now that sounds perfectly uncontroversial until one remembers that the United States is not such a country. The United States is a country completely incapable of regulating its science, mostly because, of course, the federal government does not have power to legislate over what happens in individual states. And as we know, many of those states go their own way, some banning perfectly respectable activities like termination of pregnancy, and others states banning all sorts of science. But of course it does have a very developed bioscience capacity. But the UK, however, is a country capable of regulating itself, as well as doing good science. And in the UK, any modifications that would end up in the genome of an implanted human embryo would have to be licensed by the UK regulatory body, the HFEA, the Human Fertilisation and Embryology Authority, established by Act of Parliament in 1990. And such measures would probably also need to be approved separately by the UK Parliament if it ever becomes capable of approving anything again, as had recently happened in the case of mitochondrial replacement therapy. But in the UK, we have, since 1990, had a, so far, robust and adequate set of safeguards for science, particularly for science on human beings and on embryos in particular, in place. Thanks largely to the philosopher Mary Warnock, whose report established the Human Fertilisation and Embryology Authority, and whose energy and drive and compassion drove it through and garnered public support for the legalisation of not only embryo experimentation in the UK under the safeguards in that act, but also for, if it is approved by Parliament, gene editing, which hasn't been approved by our Parliament yet, and mitochondrial replacement therapy, which has. So all of that is by way of background. Sorry about that long preamble. I amble a bit, but I also do rather too much preambling. What I want to turn to next is the objections, the principled objections, not the practical objections, some of them are issues of safety, which I'll come back to, but the principled objections that have been made to tinkering with human genes, and in particular, tinkering with those genes that may end up in the genome and therefore get passed, the changes made will get passed on from generation to generation. There are three main, and I think entirely fallacious and spurious objections that have been made to this, and I'll try and make a case as to why they are. The three objections that have been made, I'll list them now and then deal with them in turn. The first is that gene editing is wrong because it affects future generations. Sort of end of story. The argument being that the human germline is sacred and inviolable. And that idea that the human germline is sacred and inviolable, I'll come on to some various universal declarations and laws that have tried to make good on that claim. The second argument I want to deal with is that germline changes constitute an unacceptable risk to future generations. And the third is that the inability to obtain the consent of those future generations to what will affect them means that we must not ever use gene editing or any other alterations, deliberate alterations in the human genome. And I'm going to argue that all of those objections are a load of nonsense. Not only are they a load of nonsense, they are a load of ill-informed nonsense. I hope to make good that case this evening. We should be clear, however, that there is almost always no viable precautionary approach. People always invoke, certainly in European legislation, the so-called precautionary principle, which says, broadly speaking, that dangers should always, and disasters should always be considered more probable than benefits, and therefore that we shouldn't do anything which looks incautious. But I think that the precautionary approach is fundamentally flawed. There is a saying in jurisprudence, in the philosophy of law, that justice delayed is justice denied. Well, therapy denied is also therapy denied. And if we can make changes that will treat or cure serious illnesses, or even not so serious illnesses, then it's unclear in which direction precaution lies. If we don't make those changes, people will go on suffering from the diseases that they might have prevented, or the conditions that they might have prevented. If we do, of course, things may go wrong. But there is no coherent way of distinguishing whether precaution is safer than lack of precaution in the introduction of new technologies and new science. UNESCO, in their Universal Declaration on the Human Genome and Human Rights, by the way, this was rushed through in a panic after the birth of Dolly the sheep. They absolutely threw a fit, basically, and thought, we can't have cloning, it is a terribly evil thing to do. We must make a declaration that shows that not only have those wicked people in Edinburgh, by cloning a sheep, done something absolutely, Dolly was delightful. But nobody else should do anything like that, and certainly not with humans. And their declaration absurdly endorses the notion, and I quote from it, that the preservation of the human genome as the common heritage of humanity must be maintained. Likewise, the Oviedo Convention provides at Article 13 that, and I quote again, an intervention seeking to modify the human genome may only be undertaken for preventive or therapeutic purposes, and only if its aim is not to introduce any modification in the genome of any descendants. Let's look first at this idea of tinkering with future generations. Many objections, as I've said, to germline interventions emphasize that such interventions are problematic because they affect generations down the line. But of course, all human reproduction of whatever description, whether aided by technology or science or not, is like that. Sex is a genetic lottery, and a very random one at that. It's a very dangerous activity indeed, sexual reproduction. I hope nobody in this room has either benefited from it or attempted it, because it is very, very dangerous for the actors as well as for the possible resulting children. Risk of sexually transmitted disease and so on, not to mention possible emotional side effects, are beyond the scope of this particular talk. But it's worth remembering that every year an estimated 7.9 million children, 6% of total births worldwide, are born with a serious birth defect of genetic or partially genetic origin. It's a staggering figure. And additional hundreds of thousands or more are born with serious birth defects of post-conception origin, including, of course, maternal exposure to environmental agents, teratogens such as alcohol, rubella, syphilis, iodine deficiency, and so on, that can harm the developing fetus. Sexual reproduction also is grossly inefficient as a reproductive technique. It is estimated that 1 in 3 to 1 in 5 deaths occur of embryos per every live birth. If the gold standard of permissible risk to harm to future generations is sexual reproduction, and what other gold standard do we have, then new technologies would have to be really disastrously dangerous to fail. If sex, I want to suggest to you that if sex had been invented as a reproductive technology, sexual reproduction, rather than merely found as part of our evolved biology, it would never have been licensed by regulators. Far too dangerous, far too inefficient. So I hope you're all going to take that to heart. Right. The other thing I just want to mention very briefly is that the alternative, for example, to mitochondrial replacement therapy, the first genome-altering therapy that has been permitted in this country and is so far not officially permitted anywhere else, but though it is undertaken in various other countries. We know that many women will continue to desire their own genetically related children, and will continue to have them if denied access to mitochondrial replacement therapy. At the Washington Summit I attended, we had very moving testimony from women with mitochondrial disease who desperately wanted, and I don't think it's necessarily rational to want your genetically related children to yourselves, but many, many people do passionately want that. And we had very moving testimony from women affected by mitochondrial disease that they would have children if they couldn't use the therapy to remove the diseased mitochondria and replace them with healthy mitochondria. Let me turn now to the second technology, very briefly, the use of the fully fledged gene editing technique, particularly Crispr Cas9, but there are other techniques, but this is the one that has, I'm sure its inventors will get the Nobel Prize for very shortly. Many of the arguments that I've rehearsed about also apply to things like the use of CRISPR. In a recent statement on the NIH, that's the National Institute of Health in the United States, that are minders for all federal funding of health science, that the use of gene editing technologies in human embryos is problematic. This warning was issued officially by Francis S. Collins, I think still director of the NIH, who stated, and I quote, "The strong arguments against engaging in this activity, namely gene editing, remain. These include the serious and unquantifiable health risks, safety issues, and ethical issues presented by altering the germline in a way that affects the next generation without their consent." Now, of course, serious and unquantifiable safety issues attend the introduction of every new technology of any description. We have to take them seriously, but their mere existence can't be an objection in itself to introducing new technologies. Collins, though, thinks one important difference is the absence of consent. I hope it'll be obvious to everybody in this room, but I'm going to belabor the point for about a minute and a half. Consent is simply irrelevant here for the simple and sufficient reason that there are no relevant people in existence for future generations capable of giving or withholding the consent to have been affected in these ways. How could they? We all make decisions all the time for future generations. Decisions about what sort of environment they'll be growing up in. Decisions as to timing of birth and all sorts of things. We have to. How could we not? Decisions first and foremost, in most cases, of sexual reproduction about what genetic endowment is likely to result from the combination of the genes of two different genomes. Unless we're using cloning, of course, where there's only one genome involved, or more complicated or more complex combination of sets of chromosomes. George Bernard Shaw, we all know this lovely story, George Bernard Shaw and Isadora Duncan were famous exceptions when she apparently said to him, "Why don't we make a baby together? With my looks and your brains, how could it fail?" To which she received the rather more sober response from George Bernard Shaw, "But what if it had my looks and your brains?" In any event, neither of those reasons were good reasons to prevent them reproducing. I give an example from my own case. I am the result of a really reckless parental decision to which I was not party and to which I did not consent. And I will tell you what it was. I'm a baby boomer, one of the first generation of baby boomers. I was born in 1945. Why was I born in 1945? Because my Jewish parents, living in London were not prepared, they had my sister in 1937, were not prepared to have any more Jewish children, or children that would be regarded as Jews by the Nazis, when there was any probability of Hitler winning the war. So they postponed conception for the duration of the war, and only in the January or whenever it was of 1945 did they have a go again and think it might be safe. Now, they didn't consult me about that. They did an existence-changing set of decisions without consulting me at all. How could they consult me? I don't think it was wrongful, but of course it was very unfortunate for all the children they might have had in the intervening period that they didn't have. So that objection, the idea that we have to think about the consent of future generations, is just an absurdity. Let me just say a bit about human-animal mixes in biology now, just because they are becoming relevant for reasons that hopefully I'll have time to develop. The news that a combination of stem cell and gene editing technology may soon enable scientists to grow human organs in pigs is cause for serious reflection, not least because those organs may actually be superior to human organs either available from human cadavers or from other animals like pigs, which have been themselves without having human hearts, which have been one candidate for improving transplant availability. The existence of so-called species barriers is often invoked against such a prospect, but the reality is that humans and animals have been exchanging bits of their biological matter, intentionally or by chance, naturally or artificially, since time immemorial. We do it in drugs and in vaccines and in diet. Diet is a very good example, except for vegetarians, for whom objections are usually rooted in moral issues concerning animal welfare rather than in those of species mixing. There doesn't seem to be any preoccupation with the entry of animal genes, cells, tissue and muscle and other bodily products into our daily metabolism. We do it if we're not vegetarians all the time. And we know that diet profoundly influences our bodies, both at genetic and at epigenetic levels. So really, if one were consistent in maximizing the purity of human matter, the only diet of choice would be cannibalism. It may catch on again, who knows? A report by the United Kingdom Academy of Medical Sciences back in 2007, of which I was actually a co-author, noted, and I quote from our report, "There are thousands of examples of transgenic animals, mostly mice, it must be admitted, containing human DNA. The world has not fallen apart." There is a genuinely problematic issue here, noted recently by the US National Institutes of Health. They fear that the presence of human cells in the modified animal might humanize the animal's brains to the extent that they came to possess human-like consciousness. The cells might migrate to the brain, entirely possible, though unlikely, and humanize, in some sense, animal brains. This, I don't know, it's been very interesting to think about whether this will be a disaster for the animals, or whether actually, just as with other forms of human enhancement, why should we not benefit animals by improving their brain capacity if we can? The problem will be, not so much for the animals, which are humanized if it happens, but that such capacities would not just merit moral and legal protections, rather of the sort that hopefully we extend to one another. In short, such animals becoming more human would come to have rights analogous to human rights, and indeed would necessitate taking the human out of human rights, which is the name of the paper I wrote some years ago, and also discussed in my book, How to Be Good. This, by the way, is one of my quarrels with the humanists. Since you're all humanists, except me. I'm listed as a patron of the humanists, and I think the Humanists are a wonderful organisation and do huge amounts of good. And as Tricia so kindly said in her introduction, I've done some work for the Humanists in trying to liberalise the abortion laws of Northern Ireland as a result of 2 scandalous recent cases, which would be the subject of another letter. But I don't think of myself as a humanist, largely because it seems to be a speciesist approach to what gives value to a type of being. I don't think any of us are valued because of our species membership of our particular species. We have to be aware that other species may be morally important and ought to be morally protected. It may be the case, almost certainly it will be, that we will develop artificial intelligence to the point where AI will inhabit creatures, although they may not look very much like humans, they may not look with arms and legs and walk about, but with intelligence comparable to possibly even greater than ours. I think that certainly hasn't happened. AI has been overhyped, but it, I think, inevitably will. And then we'll have to think about extending the community of humanists to creatures that have no flesh and blood in them of any description, whether animal or human. But they will be persons, properly so called. My own view is that person is the relevant moral category, because there's a wonderful term actually invented by John Locke, the late great John Locke, English philosopher, way back in the late 1600s, I think it was, when he defined person. He deliberately chose the term person rather than human as a forensic term, as a term of art. And he defined a person as a thinking, intelligent being that has reason and reflection and can consider itself the same thinking thing in different times and places. Went on, I could quote the whole of it. It's a wonderful passage in the Second Treatise on Government. But for me, it has the advantage of making the class of morally important individuals open. It may come to include animals, it may already include animals. Will certainly come to include persons, and of course it may include persons from other planets. This is a long digression. I may not continue with the rest of this lecture, but just to continue with this part of it for the moment. Suppose, well, are there philosophers? I started by mentioning that I was a philosopher. The great thing about philosophers, I always used to say to the vice chancellors and presidents of all of the universities that I happen to have been employed by for my relatively long career, that the great thing about employing philosophers is that they're cheap. We don't need labs, we don't need lab equipment, we don't need animal houses to do our experiments. We just do thought experiments, we think about things. And so actually we're the best value for money in the entire academic universe. I hope I'm convincing you of that fact by this talk this evening. But anyway, suppose this is a thought experiment, which is why I gave that little aside. Suppose instead of us finding persons on other planets, on those other planets, in deep space, they turn up on our doorstep and find us. What could we say about ourselves that should convince them that they had found persons on other planets, and that we ought to be treated at least as well as they treat one another? Suppose they turn up on our doorstep, so to speak, after their very long interplanetary journey, tired, irritable, and let's assume that they're organic like us, hungry. What could we say about ourselves that ought to persuade them that we were the right sort of beings to invite to dinner rather than have for dinner? Because we might need very badly to be able to do that. And it wouldn't be in virtue of our species membership, because we might not share species with them. So we'd have to think of something else other than being a human. Anyway, that's a digression. Let me come on to, as it were, the important scientific part of my talk, if there is one. The best combination of evidence and informed scientific opinion so far does not support the idea that attempts to grow human organs in pigs will result in any humanization of pig brains. But unless this work continues, we will never know the answer to that question one way or the other. Harvard's Professor George Church, who has led research on chimeras, animal-human or animal-animal mixes, suggests, and I quote, gene editing could ensure that organs grown in pigs, so you transplant the cell that is already, as it were, specializing into a human heart into a pig. It develops as a human heart in the pig, but otherwise, as it were, shares all the pig's metabolism and its support systems and so forth. Gene editing, Church says, could ensure that organs grown like that in pigs are very clean, because there will be a danger of contamination with porcine diseases because they were grown in pigs, and other things that would not be very good for us if translated from the pig to us. Church says that gene editing could ensure that the organs are very clean. They could be cleaned up by changing, getting rid of any of these deleterious genes, available on demand and healthy, so they could be superior to human donor organs, human to human donor organs. Cleaner, more chance of being successful. And a company called eGenesis, the spin-out of George Church's lab, showed in 2015 that using gene editing, they could eliminate viruses that lie latent in the pig's genome. If Church is right, the prize is truly enormous for human beings in terms of human health and happiness. In the US, an average of 22 people die each day waiting for transplants that can't take place because of the shortage of donor organs. In the UK, the figure is 3 people a day, 1,000 people a year, who die waiting for a transplant. Globally, preventable deaths for want of donor organs and tissue run into hundreds of thousands. If we could grow them ad lib in pigs by just the transplanting of a single cell and cleaning it up using CRISPR and other gene editing techniques, it seems to me that it will be criminal not to do that. Therapy delayed is therapy denied, and that denial costs human lives every day, day after day. Of course, and this is an important point, and I don't minimize it, but I won't dwell on it, pursuing this research will cost animal lives, and this should not be taken lightly. But no society and no person that stomachs the eating of meat can consistently object to animal research directed to human health and safety. When I was on the Animals Committee of the various national scientific societies, one of the things that we had to take notice of, and indeed when I was a professor at the University of Manchester, which I was for many years, my office was in the medical school in the Stopford building, which also had an animal house. And we used daily to have animal rights protesters outside our building protesting at the work that was going on inside it. Fine, I have no quarrel with the protesting. But they were never outside Sainsbury's, which kills many, many more animals than we ever did at the University of Manchester. Why not? It's very interesting that the serious anathema with which animal experimentation is concerned, attracts, does not extend itself in the same way to farming, and certainly not to meat eating. Perhaps it should. It's another argument for another day. I'm going to speak for 4 more minutes. Do you think that's permitted? Can you start with 4 more minutes, even though I'm said nasty things about animals as well as about sexual reproduction and all the other monstrous things I've said this evening? Fine. Just let me end on a different note. We know for sure, and let me offer you, I love doing this. This is the controversial thought that nothing was controversial up till now. We know I'm going to offer you two truths about the future. It's a brave person that offers truths about the future, but these truths about the future are as true as any truths about the future could conceivably be. And you might think that are not very true, but anyway, and they are these. In the future, there will be no more human beings, no more humanists, and no more planet Earth. Let's deal with no more humans and no more humanists. Good or bad thing, probably bad for us. But why? Well, either we will have wiped ourselves out by our profligacy and stupidity, as we are doing at a rate of knots at the moment, or we will have further evolved. Either way, I don't think it's probable that human beings will survive far into the future. Could be wrong, but I think it's pretty certain. But for sure and certain, there will be no more planet Earth. We know that the dying of our sun will make this planet uninhabitable. Now, interestingly, the calculations of when this might happen were down to Stephen Hawking. And his first set of calculations, about 10 years ago I think it was, he worked out that we probably had about 7.5 billion years to go before the Earth became uninhabitable, which you may think gives us a comfortable margin to grow up our grandchildren and hope for the best. But a couple of years before he died, he revised that calculation quite recently and said that he didn't think we would have more than 1,000 years left unless we took radical steps to preserve our planet. And many people think it's even less than that. Well, current gurus, the former astronomer royal and president of Trinity College, Cambridge, wrote a book a few years ago called Our Final Century. And he was speculating, very respectable scientist, that this might be our final century. So we need to take radical steps. I hope that we will do so. And we need science, whether we like it or not, in order that we and our successors will have a chance to survive, to experience any future at all. Talk, for example, of moratoria on science or particular areas of science, like having a moratorium on gene editing, in the name of precaution and safety, may in fact be the opposite of working towards precaution and safety. I would like to end by suggesting that we must surely proceed with scientific research on CRISPR and on other germline modifying techniques to the point where we can properly assess their likely safety in humans, which we certainly can't do if we don't pursue them both in animal research and in embryonic research. We need to know whether they can be made safe. And of course, when I say safe, I just mean safe enough. Nothing is safe. And safe enough is case specific. Things that are safe enough in some contexts will not be safe enough in others. We need the better to understand all sorts of genetics so that we can harness methods available, or that might become available, to make the world a better place, which I believe it's our duty to do, and to make better people, if we can. I've written a lot about human enhancement, and I would like to, many people think we shouldn't try to enhance human powers beyond the norm. And I want to end just by suggesting to you that we humans are the sort of creatures who feel we must do that and are quite right to do it. We have always been inveterate human enhancers using all sorts of enhancement technologies. This is a lovely piece of enhancement technology that I'm using now, but even more, we, at the moment, everybody in this room is benefiting from one of the most dramatic and exciting, you're quite right, sir, you're looking in the right direction, synthetic technologies, synthetic sunshine. We are bathed in synthetic sunshine in this room. Before synthetic sunshine, our ancestors used to go to sleep when it got dark, and do other stuff, some stuff when it was dark, otherwise you wouldn't all be here. But without the invention first of firelight, lamplight, candlelight, electric, we wouldn't have had this wonderful artificial synthetic technology which has improved all of our life in all sorts of ways. Yes, we've got some nasty stuff too, and we have to learn to find out quicker when we're doing something pretty stupid. But I think it's our destiny and our fate to use technology. And technology is one of the two ways we're going to get out of the mess we're in. The other is by using less resources, burning less carbon, and having less children. Much less children. Fewer children. That was an English literature major, but never mind. That's all. Thank you very much.
I think that was yes. So who'd like to kick off? Question? Yes.
May I? Yes. I'm not a geneticist, so...
Neither am I. So don't ask me any genetics questions. Sorry.
No, well, you're allowed to throw bricks at me and call me an idiot if you think I ought to know the answer to this. There was a question when I went to university that I didn't understand, and I still don't understand it, despite your eloquent lecture stuff. Given that we want to talk about this thing called gene modification, splitting, call it what you like, doesn't really matter. Given that that is in some respects successful in some cases, my body has got trillions of bloody genes in it. How the hell are we ever going to modify my genome?
We don't have to do them all.
So the question is about how does one modify
Any geneticists in the room who can help us out here, you don't have to modify them all, usually, because genes have, a lot of genes are thought to be just junk, but the ones that aren't junk have specific functions. And so to get specific modifications, beneficial ones, you don't necessarily have to modify that many genes. But geneticists here will tell me if I'm wrong.
Now, can I come back to you on that? I mean, it sounds reasonable until you think a little bit further.
But of course, if you do it in the embryo, then
Second?
if you do it in the embryo, if you can do it in the very early embryo, when there are very few
That's what I
cells.
was going to come back and say to
Yeah,
you.
yeah.
To which I would like to come back to you, if you don't mind, sir, and say, well, yeah, but the embryos all got lots and lots of genes. Would it not be better at the zygote stage, which is where there's even less of a amount of genes?
Well, this of course is, I mean, there are some things you can do. I mean, the mitochondrial transfer is done at a very early stage, the zygote stage, or even at the egg stage, I think. So even before those are zygote, before the egg is fertilized, the faulty mitochondria are replaced by healthy mitochondria. So there are lots of things you can do when the organism is very simple. But I shouldn't start talking about this because it's not my field.
So I think we'll move on to the technical aspects, but I mean, it's to do with splicing little bits, isn't it, of our huge pinning and noticing where there are bits that cause spinal bifida or cystic fibrosis.
One last quickie bit then, if I may. So, if it was found that I have got some terrible disease and I'm going to die soon, but science discovers that there's something in my genes that's causing it, and genetically that can be changed, am I too late to have that because I've got trillions of genes, or are you saying no?
I have no idea. It depends what it is that you've got.
Thank you very much for that.
In principle, no.
Please.
I'm not a geneticist,
But you know more than we do.
but genes actually do replicate.
Yes, of course. Yeah.
So you don't have to replace every single gene in your body.
No, exactly.
Adam.
John, thank you for a very informative talk, and you obviously did positive about it, that's good. At the beginning you did cite the problems with regulation and so on, especially numerical and so on. Could you describe what you might regard as a worst case scenario in a non-regulated world, and what we can and should do to avoid the worst outcomes of inappropriate gene editing?
Well, look, I mean, a very good example is the one that was in the press very recently in China, where, I forget the scientist's name, but where he used gene editing to reduce the risk of contracting HIV in the resulting embryo. And that was the first in human, and what he wanted to do, of course, was be the first scientist to make a first in human use of this particular technique and become famous or notorious for it. I think why many people thought it was dangerous and reckless, and I'm among the people who thought that, was because firstly you have to be very careful of going first into human, because we don't know enough. I don't believe we know enough. Most scientists don't believe we know enough yet to go first into humans with the alteration of human genes using CRISPR. But secondly, it was for a pointless purpose, because while it would be very good to be immune to HIV, there were other ways for this particular human, I can't remember what stage this was, anyway, for this human infant to have been protected from HIV through sperm washing techniques and other ways at that stage, i.e. it was to prevent transfer from the parents of HIV, not to prevent sexual transfer later on in their life. And so China is, as far as I know, completely unregulated in this regard, and we just went ahead and did it. And of course, if it had gone even more wrong than it did, that might have set science back all over the world.
You implied that you felt that because of the federal state share responsibilities in the states, that it was difficult to have adequate regulation.
Well, they have no regulatory body.
Okay, so what do you think the dangers might be? What sort of things might happen when you don't have a suitable regulatory body?
Well, people might do what they want. Now, then it depends in what. It's rather like saying what might happen if we didn't regulate road traffic, let us say.
Right.
Or we didn't regulate all sorts of things that without regulation might cause particular sorts of damage. Everybody in this room is very heavily regulated. There's lots of stuff we can and can't do. Most of it we take for granted. Some of it is very invasive indeed, but we accept it. For example, jury service, which might involve everybody's obliged to serve on a jury if they're called. And I'm now immune because I'm over 70, but from the age of whatever it is, adulthood, 18 to 70, I think it is, or maybe still 21 to 70 because it's an old legislation. You have to serve on a jury if you are called to do so. And of course that may involve months of effectively being imprisoned in a jury box all day and not being able to go back to your families at night because you can't discuss the case with anybody outside the court and so on. That's incredibly onerous. So we are absolutely inundated with regulation. So I can't answer the question unless we have a specific idea of what the danger might be.
And you're talking about the philosophy of regulation, which is obviously a big subject, but I was thinking of, we have our Mary Warnock, Human Embryology, what's it called?
The Human Fertilization and Embryology Authority. Yes.
Human Fertilization and Embryology Authority. So that, what are some of the restrictions that has put on, which they don't have a comparable thing in the States? So what?
Well, any experiments on it's the Human Fertilization and Embryology Authority, so it has to do with the early human organs and
Yes.
embryos
Yes.
and fertilization, and any techniques for that or research on human embryos has to be licensed case by case by the HFEA, which means that each individual protocol for a particular piece of research has to go before the licensing authority and receive a license. And in the case of a very dramatic change, like the legislation which resulted in the permission of mitochondrial DNA transfer in human eggs, it required an act of parliament to even allow it to get as far as the HFEA. So it's a very rigorous system that we have in this country, which we've had since 1990. I think no other country in the world has anything comparable, comparably rigorous. One or two have taken up similar licensing authorities, so we know it, and we've been lucky. I mean, you have to say, however good the regulation, however good the police force, however good the laws, there are still likely to be mishaps, but we've been pretty lucky in our research. Now, the one notable piece of British science which would have been regulated by the HFEA, which was the cause that the HFEA was set up in the first place, and that Mary Warnock's report was, I knew Mary Warnock very well, I might say, was very sad her recent death. We had both criticised one another's work quite vigorously in academic papers, but we got on very well. Where was it?
You were saying there was one example.
Oh yes, it was of course the birth of the first so-called test tube baby in this country, the birth of Louise Brown, which came about in an entirely unregulated way. Well, I can tell you how it came about. Are we up for about 60-second anecdote?
Yeah.
I knew both Patrick Steptoe and Bob Edwards personally, because I was involved in this sort of philosophizing, this sort of thought about this work, when Louise Brown was born. And I think it was the first university to invite Patrick Steptoe to come lecture on what they had done. And I subsequently got to know Bob Edwards very well. And Bob Edwards told me how they got together. And it was like this. Bob Edwards, in his lab in Cambridge, he was reader in embryology in Cambridge. He liked to work listening to Woman's Hour in the afternoon, as I do. It's a wonderful program. It's been going probably since before I was born. It's a very informative program. And he was listening to Woman's Hour, and there was an interview with Patrick Steptoe, who was an obstetrician and gynecologist, who said, well, if only I could do this, this, and this, I could treat a whole range of women for infertility. And Bob was jumping up and down in his lab saying, I can do that, I can do that. I do it in mice every day, I've done it for years. And he got on the telephone, he found Patrick Steptoe's phone number, got on the telephone to him and said, I can do in mice successfully, and I've done it for years, in thousands of mice, what you were saying you wish you could do in humans. I see no reason why we can't do it in humans. And it was entirely unregulated, so they got together.
So there was no regulation.
There was no regulation of that, and they were lucky. Now, Bob would always say, well, we weren't lucky. It was based on years and years of successful work in animals. And years, sorry?
Just to follow, you
Yeah,
know,
please.
you're painting all the good things rather than the bad.
I am.
Is it possible that somebody could conceive a Hitler-type person to create a master race by genetic editing, or to use it as a form of biological warfare, for example, you know, where it is criminally abused?
If you had ad lib the ability to use various interventions to create, I mean, people said this about cloning as well. You find a good soldierly physique and attitude, and then you clone it and clone it and clone it. mostly those are fanciful scenarios, not least because mad dictators want armies now. They don't want to wait for them to grow up from embryos for 18 years when the dictator may well have been deposed and so on. So it's not a wonderful scenario. And of course, it's also, however good the raw material you might think it is, so you want an army of very strong people that you turn into so-called master race. Not a very good, master races do not have a very good history, not least because fortunately human beings so far are autonomous. They make their own decisions. And however much you might want people to grow up to do X, they don't necessarily do so, however much you might want your children. It's quite successful actually with religious indoctrination, it has to be said. But I think that I'm not worried about people trying to create, it's just too long, the gestation period, I mean not just the 9 months pregnancy, but getting them to a stage where they're usable and thinking that they will stay usable and passive and obedient through all of that stage is, we humans have not found trouble in recruiting armies for purposes. We don't need science to help us do it, unfortunately.
Any other question? Yes.
What about a possible brave new world kind of situation? Brave new world situations in which, depending on your ability to afford genetic enhancement, you can continue, and which could, create further stratification and classes.
So the question is about a brave new world scenario and the stratification, the sort of the alpha, beta, gamma, delta, yes.
Well, yes, you could conceivably use it for that purpose if you could do it in sufficient numbers to make a dent. But it's more probable it would be used for human enhancement purposes, and rightly so that instead of creating a very large underclass that you could exploit, actually you want to create more brains, because God knows we haven't got enough intelligent people in the world as it is. And those people would do what they want. So I don't see that, I don't myself see that as a danger.
But in the sense of people being able to afford therapy, so for example,
People being able to afford what?
So being able to afford genetic enhancements for their children, so giving genetic advantages such as intelligence to their children.
So the ones with money can have their children enhanced, and the ones without money
will remain, sort of creating a greater difference in society.
Is that a baby?
Well, you could try to do that. But unfortunately, people tend to turn out differently, like everybody in this room. You can give advantages, but the more people you give advantages to, the less advantageous they will become. And if we could, I think the best, or if you like, the worst that could happen is if you could make kids more amenable to education, more educable, so that you didn't have people who failed school. If education, you still need education because you can't impart knowledge with technology. You can impart the ability to absorb the knowledge or to use it with by making people brighter. If education could start from a higher base, it would just be easier to educate children. They might go further, but there would still be differences. But I don't think anybody wants to create an underclass. Quite the reverse, really. People would want to create more, but we allow them to do that. We allow people. I've spent my life as a university teacher, pretty much, and I'm very proud of the fact that for the 36 years I was a professor and a lecturer at the University of Manchester. I was very proud of the fact that I was teaching at one of the best universities in England. And I was very proud of the fact that we encouraged students to come to us because we were good and better at educating than other universities. Now, is it wrong to try to be a better university than some of the other universities? And is it wrong to, should I have downplayed the sort of education in philosophy I tried to give my students to make it sure that it was no higher than the lowest level of education in philosophy that you could achieve? Why would anybody do that? I don't think I was doing anything wrong. I don't think we're doing anything wrong when we educate people who want education and train people who want training. And of course, there are lots and lots of differences. It would be I see no point in using it in technologies to do anything but to try to enable people who are struggling with education to be better at not having to struggle. I can't see any society that would do that.
Well, a society might want people to do their dirty jobs.
I can give you an example.
But that would be wrongful. What it would be wrongful is to want and to force certain people to do, as you call it, the dirty jobs. That's what's wrongful, not to give people an education that might enable them to do other things. So perhaps to invent these poor artificial intelligences that we soon have to do these dirty jobs for us, who will very soon down tools and tell us that they're taking over. Yes, sir.
Yes, Jim.
I can give you an example of a government that has tried to do that.
Sure.
The Singapore government, I don't know what they're doing now, but about 20 years ago, they were offering tax incentives to graduates who married each other, or to non-graduates who married each other, and tax deficiencies, or to those a graduate marrying a non-graduate. They were trying to create a top class and a worker class. My son was living there at the time, and so I know that. So that is something that people think about. Governments
Sure. But that's what's wrongful. What's wrongful? What's wrongful is not giving them better means to create more intelligent people or people better at certain with more skills. What's wrongful is excluding some people and using that education or those skills for wrongful purposes. People will, unless you abolish choice in marriage, and of course people do choose people very like themselves. Look around you. People choose people very like themselves. And this is the George Bernard Shaw and it wasn't actually, another footnote to history, it wasn't, I researched this, because I never use a footnote in my writing without researching it. It actually wasn't Isadora Duncan, but I found an interview with George Bernard Shaw saying, yes, it was an actress. It wasn't Isadora Duncan, but I won't name her.
There's a question here. Do you have? Oh, I thought you had.
Well, I was thinking of asking one, but I'm quite interested in I'm interested in the whole thing, but the ethical point, which keeps cropping up, whereby it's always regarded as worse to actually choose to do something than to choose not to do something. In other words, if harm happens because you've chosen not to do something, that fairly universally, the people that go on about tinkering, etc., which is an insulting term, it's always regarded as worse to do something than not to do something, even if the consequences are either way.
I'm glad you asked me that question.
And how do you get that point across?
Well, I'm glad you asked me that question because I wrote my PhD thesis on exactly that point. And let me give you just a little gestalt of my answer. Let us take, Tricia will forgive me for this, let us take this tabletop and its immediate surroundings as an example of a world that in which I am omnipotent. So I can change the state of this world. I can do it by moving that to there, and that has changed the state of this world. And then looking at the world and thinking it good, I can leave it as it is. Those are two equally effective ways of determining the state of this world. I can move in it, and as long as I have the power to move, I can decline. So acts and omissions, for me, and as stated in my PhD thesis, eloquently and decisively, there are two different ways of making things happen. To give you another way of thinking about that, decisions are decisive. If decisions weren't decisive, we wouldn't make decisions. And sometimes we decide to do things, and sometimes we decide to leave well alone. And each of those sorts of decisions have an impact on the world. Not just the doing, but the deciding to leave well alone. I used to teach medical ethics to medical students for 20 years. I taught medical ethics to medical students. And when I started teaching medical ethics, there was this medical aphorism in medical ethics, magisterial inaction, when you can't make a patient better by doing things, you just leave well alone. You just don't intervene. And that's, you couldn't actually have that dilemma as to whether to make an intervention or not to make an intervention if not making it was equally effective in determining what happens as effective. So I just don't think there is that distinction, although it's a very tenacious distinction.
Most of
And
us.
unfortunately, the entire world has not read my PhD thesis. I cannot think why.
Yes.
You've led to my very question about ethics and medical science and reducing suffering and improving health. Where's the tipping point where it's advancement in adding advantage as opposed to removing kind of defects, like Hodgkinson's?
Well, I think it's a continuum. I think there is no therapy and enhancement are on a continuum, and I don't think that there is a moral difference in any of the divisions on that continuum. So I don't think it is morally more required to do therapy rather than to do enhancement. If we can make things better for people, we should do so, regardless. They shouldn't have to qualify for having things made better by being ill, or being sick, or being injured, or being damaged. They shouldn't have to qualify for interventions in that way. If we can make the world a better place and people better people, we have moral reasons to do so, regardless of the starting point. Regardless of the starting point, in my view. So if we can make the world a better place, we have a moral obligation to do that. And if we can improve things for people, even beyond what are species typical capacities, then we should do so.
How about skin cancer from too much sunbathing? Could we have an enhanced melatonin?
Well, I don't know. That's a scientific question. But if we could, why would we not do it? Why would we not do it?
They have it already.
Yeah.
But why would we not do it? And the moral imperative to do it is not increased by it being understood as an illness or a defect in advance. And the same goes for improvement, for me, the same goes for improvements in intelligence, in physical ability, in sports. Enhancements in sports are very interesting. People draw a line. There is a world organization for this, WADA, the World Anti-Doping Association, I think it is, or authority or something. What's wrong with doping in sport? Well, we can have a discussion about that. If it improves performance, and it is not harmful, but is training harmful? Is the dietary requirements for being... If you want to be a top flight athlete, you have to do nothing else. You can't have a day job. And it's bloody expensive. You need a dietitian. You need several trainers. You need to be able to devote yourself to nothing else. You need the best equipment. You need the best people to compete against so that you can hone your skills, and so on and so on. Not everybody. There is no level playing field in sport. The playing fields are like this in sport, even for playing football. There's no such thing as fairness. What you have to decide, and sport, I mean, I could talk forever on sport, but it's not one of my specialisms. I have a marvellous colleague at King's College, I'm trying to remember the name of her most recent book.
Was it Matthew Syed?
No, it wasn't. Anyway, that's a further digression. But what I'm trying to say is that, firstly, it makes, to me, makes no sense to be in favour of therapy but not of enhancement. The issue is what will make people better, what will make them happier in their lives, what will make them better able to function. And in virtue of that enhanced ability to function that help to make the world a better place, that I think is the name of the game. Whether you use it with technology or with education or with example, or by religious teaching, God forbid, is a different question.
Anyone who hasn't asked one? Yes, Steve.
I was going to ask a question about sports, and you about that. Many of us here went to a lecture yesterday that Adam Rutherford gave, and Lucy asked a question about this particular issue with this lady athlete who happens to have an unnaturally high hormone, testosterone. A couple of things that weren't mentioned yesterday are there are some women's races that will only now be won by women that have enhanced testosterone.
But artificially enhanced or naturally enhanced?
I can't remember. It could be that they have gone through some kind of gender reassignment that has done so. I don't know the details, but I wanted to point out that I remember, I'm quite into cycling. I remember there was a Spanish cyclist called Miguel Indurain, who was a genetic freak. He was very tall. He had such large lung capacity that he looked fat. When he breathed in, his diaphragm came out, he actually looked fat. It was just in his diaphragm, his lung capacity was so large. He had a pulse rate at rest of 28. I don't know if you know, you're doing well if you've got a pulse rate at rest of 60. So to come down to 28 is pretty. So the point I'm making is that we can only be really good at these sports if we are genetic freaks or we take artificial advantage.
And sometimes not even then. Why are there no 5'5" basketball players? I ask myself. They're all, there is a certain, almost a minimum height for basketball to be a top-class basketball. Does it matter whether they get that advantage by the genes that they inherited, or whether they could?
Well, it means that if you're a cyclist that comes from a country that's high up in the mountains and you do all your training,
absolutely, you have an advantage.
No one else can compete with you, and it forces everyone to do that in the same way as it forces sports people to take drugs in order to compete, and that's a problem.
Well, I don't think I'm going to say something that would in any other context, make enemies of the entire audience. Most sports are ineffably trivial. They're fun. I'm a Manchester United season ticket holder. My God, what a burden that has been to me over the past few years. But so I'm not against sports. I do take them seriously and love them. And I played squash for many years at a reasonably high level. Until I wrecked both my ankles. But the point is, what the rules of sport are and what physiques are well adapted to particular sports is a function of what the sport involves. If it involves putting a ball in a basket, you have to have one sort of physique. I forgot the name of the wonderful Australian swimmer who had an amazingly large feet.
Phelps, wasn't he? Phelps?
Yes, all of these things. Is it unfair? Well, yes, it is unfair, but the world is full of that sort of unfairness, and partly that sort of unfairness is a function of the sports invented, which happen to favour some sort of body types or others, or some sort of, and the same is true of other sorts of things that people might do. Unfortunately, there is not so far any reliable evidence for being incredibly successful as a businessman through your genes. So we can't become multimillionaires just by tinkering with the genes, which might be the most divisive thing.
Well, if I can mention one other thing, that
Yeah.
some people, I don't know whether this is true or not, it is said that 25% of all Nobel Prizes have been won by people with Ashkenazi Jewish background. I don't know if that is true or not, but that's a gene potential advantage. Maybe.
I have no idea. These are imponderables. What makes, I don't think there is, so to speak, a recipe for making Nobel Prize winners, except that I worked for the last 10 years of my career with John Salston, who won the Nobel Prize in 2002. We ran a small research institute together in Manchester called the Institute for Science, Ethics and Innovation, because he was interested in applying science and making sure that impediments to science of the sort that I tried to talk about this evening were minimized. But he worked on the nematode worm, which, as those of you who know about the nematode, wonderful creature, is translucent, so you can actually see what's going on inside. So it's very useful. People either work, a lot of biology is either done on nematode worms or on fruit flies. Fruit fly, unfortunately, is not. Partly because the fruit flies, they both multiply very quickly, so you can have lots and lots of generations and see how the effects that you change work out. But he just says that what one who knows about flies, I just happened to be concentrated when I saw something interesting. And I asked myself, why is this happening? And couldn't find an adequate explanation. So I tried to have a theory as to, and that what he noticed was that some cells in the nematode were dying. And he postulated, well, he examined them, they weren't damaged, they weren't diseased. Why would they die? And he postulated they were programmed. So he postulated the phenomenon of programmed cell death, which a lot of people are working on, because if you could reprogram cells so that they did die, like for example cancer cells, this would be a very useful thing to be able to do. I don't think there was a recipe for what John achieved, except that he was incredibly curious.
Thank you. Do you have a question? Okay, anyone else? Yes.
It's just, you mentioned about this possibly being our last century, or
Not me, that was...
Yeah, that's right. But,
yeah.
But
That was the astronomer world.
Yeah, so whether genetic enhancements or could that, like allow human beings to flourish more, to be more prolific, to consume more, produce more, could that not hasten the end? Or do you think it would go the other way and we would all be intelligent enough to sort out climate change and...
Well, I hope we're not trying to create people who consume more, although of course it's good for business. On the other hand, it's bad for... We could solve all our problems if... What? If we could reduce the world's population by 2/3 overnight, only unfortunately by nuclear war or famine or
genetic
disease.
sterilization.
Or something that for other reasons we would not feel ourselves entitled to do, like violating people's will to reproduce themselves. We're in a tough corner. But I see, I may be naive in thinking so, I see science as one of the ways of trying to help us get out of this. And it's certainly not going to be done by industry, except insofar as industry is required to produce the fruits of science in quantities that are usable by large populations. But we need to do all sorts of stuff. One of the things that John Salston and I did while we were running our institute was we tried to further devise, lots of people have tried to devise this and popularize different ways of dealing with intellectual property, and patents in particular. It's one of the biggest problems of access to medicines is the cost of medicines. And the biggest problem with the cost of medicines is that people are allowed to patent things that are useful, and then they can set their own prices. And the pharmaceutical industry always claims, well, but there's a lot of R&D, and we need these high prices to pay for the R&D that we carry out. But of course, a lot of what they use their profits for is to suppress drugs, because they have one drug that's working okay, and then another promising drug is developed by a smaller company. They buy it up and suppress it. Why? Because in order to actually get it on the market, even though it would work better, they would have to do all the trials, which are incredibly expensive. So it's much easier for them to go on marketing their slightly less good, or perhaps considerably less good drug, and suppress the better, and all sorts of things like this. And the evergreening of patents. You change the molecule slightly, you get another, whatever it is, 25 years on your patent. I mean, some of the practices of the pharmaceutical industry are absolutely iniquitous and stand in the way. They do a lot of discovery as well. But that is one set of regulations that we can change. And we produce something, Google this still, we produce something called the Manchester Manifesto, which tries to set out ways in which, firstly, how the pharmaceutical industry in particular are abusing their monopolistic position, which they're allowed to have by the patent laws that we develop, and recommending possible alternatives to that. Bloody good document. Most of John Solstice's work, I have to say, I sat and looked on in admiration.
Has it been taken up at all, any of these suggested alternatives?
Well, there's a lot of, I mean, not just from us, the small cog in very big machines. One of the suggested alternatives is abolish patents and have prize funds. So you give the discoverers a prize which they can then use to develop. I mean, there are lots of different possible models for doing this sort of thing.
It's very difficult to hear because it's so noisy. Could you speak much louder?
Yes, I mean, one very good example was the drug Avastin, which I think was developed, I can't remember its primary use, I think it was a cancer drug for stomach cancer or something like that. But it was discovered that in smaller doses than were required to treat cancer, it would cure wet macular degeneration of the eye, which would cure a disease that causes blindness. And the company that produced Avastin, I won't name it because I'll probably name the wrong company and get sued, particularly since this is going to go on YouTube. But instead of just marketing Avastin in the smaller doses, which had been proved to work in lots and lots of patients, they developed a new molecule that they could then patent and charged a much higher price for it. So the dose of Avastin, which would cure blindness, would have cost the NHS for a one-off cure, I think about £400. But the drug that they engineered to replace it cost £5,000 a dose. Well, that is not nice.
Okay, another question here.
It's interesting to compare patent law with copyright law. And a patent has been valid for 20 years from the time it's registered. And in the pharmaceutical industry, it often takes 10 or 12, 14 years to get the drug on the market. So they get 5 or 6 years to recoup the costs and make a profit. Yeah. And these are capitalist organizations like any other business. The main business is giving value to the shareholders. Copyright law, on the other hand, copyright lasts for 75 years after the death of the copyright holder. So the children and grandchildren benefit from the invention of the copyright holder. I mean, that's a big anomaly, isn't it? Don't you think?
Yes, it is, but most authors do not, unless they're multi-selling, unless they're J.K. Rowling, do not make a lot of money from copyright. All of the things I write are copyrighted. I would be only too pleased if people produce them in multiples and I got no income from them, so long as people read them. One of my, still a friend of mine, I think one of the best philosophers still working in England, still alive, very active, is Jonathan Glover. And I met him when I was a graduate student in Oxford, and he was at that time a lecturer, a fellow in Oxford. and we've been friends ever since. And he once said to me, way back in the 60s, you can't patent thought. You shouldn't be patenting what we do. If people use my ideas, good luck to them. I feel the same. I feel the same. I write books, don't get much money from them, but it's not to stop other people using the ideas in them. I'm very happy to be plagiarized. Just like to be mentioned.
But drug R&D does cost a lot more, doesn't it?
Well, it depends what types of costs we're thinking about.
Well, pharmaceutical, I mean, it costs $1,000 million to do a good job for them. And you've got 5 years in which to recoup that.
Yeah. But we have to operate, if we're going to reform all of that, I mean, I just talked about one part of it, we're going to have to look at the cost of developing drugs as well. And one of the biggest costs, and I'm not a Brexiteer, far from it, I'd love us to stay in the European Union, but the European Union has the worst sets of obstacles for bringing drugs to market and licensing them. And we need to have much simpler ways of doing that. But that's another set of stories.
Right. Well, I think we're coming up to the time now, so we ought to draw this to a close unless there's anyone wanting to ask a question who hasn't. Many of us will be going to the pub. Remind me the name of the pub?
What's the one called? The Enterprise?
The Enterprise. The Enterprise. And I think John's coming along with you. So if you want to continue this discussion, do come and join us at the Enterprise. Just go out and round to the left as you go out the front door and up there.